Hi there, today I'm talking about TMV, assembly and movement. Before you watch this video, I suggest, just so you're caught up, go watch the previous video. It will definitely help with this one. Here we go. So first of all, I'm going to be talking about tobacco mosaic virus and how it's assembled. So if you watch the previous video, you can see that tobacco mosaic virus has created a protein called a coat protein, 17.5K, which is the molecular weight of it, and 30K protein, which is a transport protein, which will both be vital for the assembly and movement of the tobacco mosaic virus. So once we have, or if you look back at the last video, once we have the virus has made lots of RNA replicas of itself and lots of coat protein, it'll be able to wrap up the viral RNA again, ready for movement. So how does it do this? There is an OAS, which is the origin of the origin assembly site. It's origin assembly. This is where the coat protein will first bind to the RNA. So as you can see here, the first at the OAS, the first coat protein will bind. This is mainly for protection. Here we go. Then the coat protein will, another one will join. It will have to bind to both the previous coat protein and the RNA for it to stay. And these will keep binding until, as you can see here, it fills up fully as we go all the way, fills up fully. And this will create a perfect 300 nanometers sized bit of tobacco mosaic virus. These are so perfectly sized that they used to calibrate electron microscopes. Next, we're going to move on to the cell movements. There are two types of cell movements: slow cell-to-cell movement and more rapid long-distance movement. We'll start off with the cell-to-cell movement. So it'll be moving from the plant cell here to another plant cell through the plasmodesmata. So the plasmodesmata pores are too small to allow the virus to pass through these little pores here. It's a bit like trying to get a bus through your front door. It's not going to happen. So the TMV uses transport proteins. Let me pull this one up. Here we go. The TMV, we use its transport proteins, which are able to bind to the cell wall of the plant cell. Obviously, the plant cell wall is too thick to go through, so it will have to bind to the plant's cell wall, and it will expand. It will expand the small plasmodesmata gaps, allowing just enough size for the viral RNA to pass through. Now, this will allow it to cause infection to the neighboring cells. It can be done with or without the coat proteins. They can just, coat proteins, they can bind after. This is normally short distance, as you can see, but it will take a long time to get through every single cell wall around the plant. So this is very slow cell to cell. Next up, we're going to look at long distance movement of the tobacco mosaic virus. So you can see this is the virus right here, and it's just going to be passing through the plasmodesmata into anything that can transport over long distance. So it will reach a connective tissue. So this darker yellow is the connective tissue. And it'll be able to go through around the cell through a similar process, except for it's not now going cell to cell. It's now going into the connective tissue. Examples it could have go into is the phloem or the xylem. Now, once they're in, they don't need transport protein, because they'll just be moved around naturally via the natural flow of the phloem and the xylem, just because they move up and down the plants via that. This is obviously long distance. It will go up and down the plant a lot quicker. It can infect the whole plant within 3 days, a whole tomato plant within 3 days. Very rapid, and yeah, obviously it's long distance as using the connective tissue. Thank you very much. I hope you found this helpful.